Okay, do you hear me? Can Okay, so I think we can begin the stream. Yeah, okay. Can you tell in the comments if you hear me or not? Can someone tell me? Okay, so we can begin. Okay, I got the duel challenge. I guess I will accept it. So duel is a feature which is present in the AC Discord server, which stands for accepted, and it allows users to do one versus one duels. I guess I'll. Okay, so time to prepare for the duel. Yeah, hopefully nothing will be messed up. Okay, good. So, oh, beautiful matrix. Oh, but I have this one. Okay, I need to wait until I get my handle switched back in order to do duels. If you have any questions, I guess. Yeah, I think we can do it now. Okay, uh time to do a duel. Wish me luck, I guess. Okay, time to solve this problem. Okay, so Igor has fallen in love with Tanya. Now Igor wants to show his feelings and write a number on the fence opposite to Tanya's house. Igor heard that Tanya doesn't like zeros, and we need to find the maximum number we can write on the fence. Okay, so we are given. I think that's a greedy, and we can take the biggest number, I guess. But we need to take care of the corner cases. First of all, if we can't write anything, it's -1. We need to check out, we need to find the smallest cost. And the number of digits will be equal to v divided by main cost. But we need to check out some few things. Also, we can do it like this. Because if we have multiple numbers with smallest cost, we should take the biggest one. Oh, but let's solve it anyway. Yeah, the costs are bigger or equal to 1, so we can do this. Let's check out what we did. Oh, I got some error. Oh, yeah. I should have seen that. Now let's try. Oh, time to run this sample. Oh, it didn't work like that. Time to at least see if I got the right number. Oh, I was finding the maximum instead of minimum. Now it's okay. Oh, 33. Oh, 99. So I'm pretty sure I checked it right. 3-1. Okay, here I did it okay. And V has to be bigger or equal than the difference. Oh, let's see now. We got 33. And here we should have -1. Let's sum it now and see if we got accepted. Hopefully this is the case. Unexpected error. Hopefully Code Forces is working. Oh, it got submitted. Let's check out. Oh, hopefully we don't have a queue. This would be real sad. The queue is quite big, so I guess we can talk. Since Code Forces isn't running, I guess you can ask me stuff. Don't ask me how to become as good as William. He can answer this to you. If you want to become as good as me, just in your case, not practice for like 10 years and you will become as good as me. However, if you are weaker than me, I think you can practice and do lots of contests. And I think I told most of my tips in one of the previous videos. I think it was the video about approaching contests. But if you want more general advice, there are multiple tutorials online on YouTube. I can recommend Eric To's recent video about how to start competitive programming. Oh, so since Code Forces isn't working, in order to reach candidate master, I think all you have to do is to practice problems rated like 1900 and beyond, like 1900, 2000, 2100, because nowadays you can get candidate master quite easily, I'd say. And yeah, all you have to do is to practice. Practice is the key. I think everyone will tell you this. There is no secret formula or anything like that. Uh, I think it's recommended to practice on multiple platforms because you get used to multiple problem styles, and whenever someone uh, comes with a new contest with a different style, you wouldn't be that surprised. And I think it's better. Does anyone know how to get the chat to be shown? Does anyone know how to get the chat to be shown like here? Like how the Twitch streamers get their chat in the corner? Oh, thank you. Oh, now we can have split screen, I guess. Once I will figure this out. Time to figure. Okay, I think you should see both the chat and the. Okay, I think I fixed this. Oh, nice. I think I'm done. Oh, let me. Oh, so I think I guess Yeah, I think I'll do some ad coder. Let me check the last beginner contest. Okay, I think we need to take care of someone here. Okay, so we had yesterday the beginner contest. Let's solve some of the problems. Hi. Okay, this problem is quite easy. Oh, only thing you have to do here is to check if literally the condition from the statement. Okay, time to move from to E. Okay, so we are going to eat X red apples and I green apples. And we have A red apples of deliciousness given, it's an array, and C colorless apples of deliciousness. Oh, so we have red apples, green apples, and colorless apples. And we need to, oh, we need to change the colorless apples to either red or green. And we can choose to eat while making the sum of the deliciousness of the eaten apples as large as possible. And we need to find the maximum possible sum of the deliciousness of the eaten apple. So we are given an array. I think a greedy approach may work. Like we sort the apples from all the arrays and based on so and we can basically take the biggest one at each step. But we need to be careful at some cases, I think. Or another idea might be to at first consider we take all the apples, like all the green apples and all the red apples, and at each step remove the smallest from either green or red. Let's try something and see what happens. Hopefully this is correct for the previous problem. So X, I, A, B, C. Oh, okay. We sorted the apples, I think. I think I got them in the... Oh, so those are red and those are green. Okay. Now I guess a minus x plus 1. We need to be sure to make the answer long, I think. Yeah, the answer definitely has to be a long. Okay, so I think now we can replace apples, but we need to first, at first, make the apples of outside the array to be big numbers. So let's try something and see if it's good or not. We need to check if the smallest apple from either red or green list is smaller than the biggest one from the uncolored list. I think as we can break. Let's see if this actually turns out to be good. Oh, it got 9. Oh, so let me check if I did something. Okay, so let me do some little debugging, I guess. Okay, we have 2, 2, 1, and we need to eat. Oh, okay. We need to eat 1. Oh, here. We had to make I instead of X. And here, the same thing. We got 12. Now let's see the other samples. 25, that's okay. And 74. Now let's submit and hope we get accepted. Oh, now let's see. Hopefully this turns out to be a good submission. The last test. Oh, I got accepted. I think, what should I start next? Okay. Um, time to see what our, yeah, time to see F. F or D. I think we can try out. Time to actually. Oh, wow. Okay, so time to look at both D and F, I guess. So let's see. We have an undirected graph of n vertices numbered 1 to n and n edges as follows. For each I, uh, there is an edge. So we have a chain. Oh, we have a chain. Oh, we have basically a cycle and some additional nodes. Oh, so for this one, uh, we need to find the short. Oh, the n is quite small. We can just do brute force, I think. Yeah, I think we can do some BFS. This would have been more interesting if the limit for n is bigger. But I think we can write some n squared algorithm where we basically do BFS for each node. Let's try it, I guess. I mean, since the graph is quite a special one, we can probably do some more clever ways. I invite people in comments to share their approaches if there are better than the standard n squared. I'd be glad to hear them. Oh, so we have an undirected graph. Okay, the graph is undirected. And we also have edge between x and I. Oh, now we are just going to do a BFS. The only thing we have to do, I guess, is to write a BFS. Now let's see. Oh, it's because we have this name D and we also have this. Okay, time to rename it, I guess, to Q, since it's a Q after all. Okay, time to check the examples. Yeah, now let's submit and see what happens. Time to get hopefully unaccepted. Yeah, it wasn't accepted. Distributing integers. Oh, let let's see if code force is actually fixed. Oh, still not. I guess let's redef. So we have a tree and the it edge in this tree connects vertex AI and BI. And for each k we need to solve this. Let's see what we need to solve. Okay, we are writing one on vertex k, and for each number we can write in the following order. Choose a vertex that still does not have a number written on it and its adjacent to a vertex with a number already written on it. And we need for each k to solve this problem. Let's see. I think that's a DP13. Like for for a fixed root, we can let's see, we have this, let's say we have this tree. Like we for each leaf DP is 1. Then we need to multiply, I guess, stuff. Like we need to begin from here, and then uh, we have 3 factorial permutations, like the order in which we can start them. And I think it can be reduced to some 2 DFS thing, something like that. Like if we start here, we can either go here, here. There are 6 permutations. Let me draw something a bit different. Here is 1, 1. Here we can either do one, this, or this. That's 2. And I think it can be reduced to some combinatorics, I guess. Let's see. I mean, I'm not too sure about the idea, so I guess I'm going to read the editorial and check out the idea. Oh, yeah, I think I was thinking in the right direction with the peon tree. Yeah, so it's the subtree size minus some factorial and the product of the piece from the. Yeah, sorry if someone got hurt by me reading the editorial. Oh, okay. Question asked by Mohammed. Uh, I think the best answer depends on your level. Like, let's say 1 year ago when I didn't know divide and conquer DP, and I googled educational tasks about divide and conquer DP, and I solved like one or two tasks in order to get used to the idea. So, in one hand, you have these educational tasks which will help you get better. But now you shouldn't solve tasks which will never feature at a rating closer to yours. Like, let's say if you are blue, you will never need something like dynamic connectivity. And also, you should try to solve tasks closer to your rating. Like, if your rating is blue, you should solve like tasks of 100, 200, 300 points bigger than your rating. I hope I was helpful for this question, and I also invite you to ask other questions. Okay, so let's read the strip tree. So we have a complete binary tree of depth d and n equal to a d plus 1 minus 1 nodes. Okay, and each edge is white or black. So we number the levels. Oh, each node at an odd level is connected to the parent with a white edge, and those are connected with black edges and so on. Chef's friend Alice wants to pick two distinct nodes, U and V, and the color C uniformly randomly and add an edge between the nodes U and V with color C. Excuse me. It's allowed for two parallel edges to exist between U and V after this operation. A strip is an alternating cycle of white and black edges. Each vertex may appear any number of times in a strip. Find the probability that a strip is created when Alice adds an edge to the graph. It can be proven that this probability can be expressed as a fraction. Okay, so we we have, what is this? So oh so one test is D, which is the number of the levels. Let me draw some trees. Let me make this smaller and this one bigger. Okay, so let's see what happens for, like, we have this tree, and since we are at level 0, all the edges are white. And we need to find the number of ways to make a cycle. So for this case, we can either do it like this, or I think we can also, we are given the ways actually. There are 4 divided by 12, which is 1 divided by 3. For 2, this number seems to be equal to 1 divided by 7, which is, like, if we multiply this by 7, we will end up with 1,000,000,008, which is which is congruent with 1 modulo 1,000,000,007. Actually, let me try out a formula. Okay. I'm going to I'm going to try this guess. One divided by, oh, 1 divided by x is equal to x raised at mod minus 2, since we have a prime number. So all we have to do is to compute. I will try this. I don't know if it's correct or not. Hopefully my assumption is correct. Okay, let's submit. It may be wrong. I'm not too sure about it, but it's just a guess. Sometimes it's okay to guess things which seem. Oh, it got wrong answer, so that's not the idea. Let me think more. I think, hi, Mohammed. Okay, so it didn't get accepted. Let me think more at it. For D up to 15, I think we can actually draw the tree. Let me draw a tree with with three levels. Is Code Forces again up? Oh, nice. I got accepted. Okay, let me continue with this problem and then we can move to some duels. If Code Forces is back again, of course. So we have white, black, white, black. Oh, okay. I see, Kostya. Thanks for the information. Okay. Since the tree is alternate, we can add a cycle between two nodes linked by the same color and reverse the color, I think. Like, if these two nodes are connected with an edge, like above them, it's an edge, white edge, and we can do like this, a black edge. I think for one node, we can like connect here with black or here with white or here with black or here with white. Like for each node, I think we can do something like this, but it doesn't work every time. Like it can only work for the ancestors. I think of, yeah, it can only work up to root, I think, because if we do it like this, white, black, black, this won't be alternating. So I think for uh these nodes we have one, two, D. I mean, the number of possible edges is uh 2 at 2 at d plus 1 minus 1 squared minus, oh, so n multiplied by n minus 1, since we can't add an edge between the same node, or can we? The probability is 4 divided by 12, so I think we can't add an edge between the same two nodes. Like for this tree. For this node, we can add this one. Also, between these, we can add this, but we can't add, let's say, here for this cycle. White, black, black, white, black, white, black, white, black, black. So it won't be good. I think we can add edges like this for the ancestors. I think we can also add something like this, like white, black, white. We need to add only in the same subtree, I think, in order to get back. Like we can only add one edge, right? Yeah, only one edge. So I think it has to be ending something somewhere here. Like if we fix one of the ends, if we added white, black, white, we can't add anywhere here because it would end us with a white edge. We can't add here either, so we can also add here. Let me see for a node which has stance. Like for this one, if we add edge white, black, we can add here, also here. Oh, so for a node, we can add either to its sons, I think. For each of its sons, we have a way to add. To a sons. And also to its direct parents, I think. And also to its siblings. To its sibling, actually. Like to parents, or if we have level x, we can add to level x minus 1, x minus 2, and so on. Hopefully, this is good. Should I implement it? Like, I think I have to check it if this works. This will be the numerator, I think. I always confound these ones. Like if we have a divided by b, this will be the b. Okay, now we need to find for each level the places where we can add. So for here, we can add to each of its sons the number of nodes in the subtree is 2. If we have max level n minus x plus 1, I think. We have level 1 minus 1, since we don't consider this. I mean, if we have here like white one, yes, but if okay, we can't add to siblings, so only to sons and parents. Okay, Let's see. And now? Yeah. So we can now count how many edges are good, but we need to find a way. Oh, since it's actually, I think it's actually wise to do it like this. Parents is equal to level. I want to check how does this work, like if it's working right or not. Oh, we also have to multiply, since on each level we have two at power level nodes. Still, it's not good. We need to check it for this small tree. Oh, time to extend this screen and check it for the small tree. So if we have this, are we overcounting? I think, yeah, we may be overcounting stuff. Oh, so you say we can only add two. I think we can add to this ancestor, the first one, because we can add black, white. Oh, so if we add white here, oh, white, black, white. Oh, so we can only add to odd number of ancestors. Like, nice one. Time to check. But if we count both sons and parents, if we count the parents, I think it will overcount. Like, we end up adding the same edge, and this will be considered. Let's see now. I think we are overcounting if we add both sons and parents. This is something we should care about. Oh, it got right on the samples. I think I should submit once more to check out if this will work right. Hopefully, yes. Oh, we still got wrong answer. Hmm. I mean, It shouldn't be too hard. Like, where was this given? Hmm. Maybe doing the thing like that doesn't work. Let me. So we can. For a level I, we have to what? Oh, I was getting wrong answer because I'm stupid. And I forgot to actually delete the comment lines. Hopefully this is good. But still, let me check out if I. Oh, now I deleted the uh, extract printing stuff. Oh, we got accepted. Nice. So basically, the idea of finding the edges is good, but we need to be careful at some cases, as Rohit, I think that's how we pronounce it, pointed out. And overall, quite an interesting problem. Probably it's quite easy for some of you, but it took me some time, like it took me 20 minutes, I think, and quite some observations to do. In these kinds of problems, it's easier to reduce it to each level in order to adapt to the answer easier things. Probably that's some kind of contribution technique. When will I become a 6-star coder? Probably if I will start doing code chef contests in some few contests, I think. Like I got quite fast. Oh, I mean, I only did like 5 contests on code chef. I didn't do too much. How many people are on the live? Ah, only 8. Can you tag some more people to join the live? Actually, I'm going to do it. No, I don't think you're banned. Do you have some other problems to suggest or anything to ask? Like if you don't have any questions, I don't think I will uh, keep this live for much longer. Any other question? Infinite path uh, is a problem from the educational realm, the recent one. I think it can be solved by observing that for a permutation we will end up getting the answer only if we check the divisors of the cycle length. For the ITSAS, yes, I'm a high schooler. However, I'm graduating this year. Hopefully this year. I mean, the coronavirus crisis should end this year in order to be able to say that I will graduate this year. I mean, unless we will repeat the year, yes. Uh, has anyone joined AC? Oh, a duel. I think I'll accept it. Yes. Let's see the problem, I think. It's a div tree problem. So we are given a string and we have to color all the characters in two colors. After coloring, we can swap any two neighboring characters that are colored in different colors. And we need to make these strings sorted. Oh, so basically we need to find out a subsequence, a way to split the string into subsequences in order to get the string sorted. So we basically have to find the two substrings s- subsequences, I think, which will allow us to get the answer. Since it's easy version, I think we can do a DP. The goal for this problem is to be able to do the swaps such that we can bring all the all the smaller elements in the right position. Let's try something. Mm, yeah, back to coding. So it's 200. I I mean, yeah. I think I have a solution which works for both versions. The counter will count how many subsequences we got. If the first one isn't available, and if this happens, like we are basically doing some greedy, I think. Oh, oh, okay, let's sum it, I guess. Um, Basically, I try to do a greedy. approach in order to find those increasing subsequences. Oh, we have Q again. Why? Why do we have Q again? This is fucking madness. How long is the queue? Does anyone know? I guess I guess we won't have any code forces for now. Yeah. Mike needs to work more to keep his server better. Oh. If this is right, I think I won. Hopefully it is right. Yes, he's Eva. Uh, Fantasy. Oh, running on test 6. Hopefully my solution doesn't fail. It would be uh, disastrous if my solution fails. Test 17, 19. Code Chef CCC. Uh, yeah, this problem is quite a classical example of greedy. Basically, I tried to. Oh, I got accepted. Yay! Nice. And Eva got wrong answer. When it comes to solving CSS problems, uh, I think when it comes to solving CSS problems, I think if we can do it, it's advisable to find more techniques in to solve the problem because you can learn more things. Like for example, let's solve the yeah. That's basically what I'm trying to do, Kostya. F1 is I think harder than I don't think I can solve it in the remaining time. Like I'm not going to stay for more than 20 or 30 minutes. Let's read CCC. No more duel. We have an coconut and we have to break Z of them. We are given a sequence with the following meaning. Is it possible to label the coconut through 1 through n in such a way that for each valid I, the I coconut needs to be hit exactly AI times to break? Hmm. For this problem, I think the constraints suggest a DP. Wow, wow, convex full trick. Yeah, sounds interesting. Yes, so that's harder than expected. Why did we? Oh, wow. Actually, it ends up that we can use a greedy, which is quite interesting, to say the least. Yeah, I think uh, I have 9 people. Time to look at ranking students from top quadrant. I think that's the last problem, but I don't think I'm going to say too much on it. So we are given a class. So we are given a class. Oh, for each valid I, the number of students before it should not reach Fi. And for each valid I, student A must come before student A, Bi. And we have to return possible if such ranking is possible, and impossible if it's not. I think that's some kind of topological sorting, and probably some cognitions, since the constraint for n is quite uh, light, like up to 1000. Yeah, I mean, I'm quite tired now because I had the 5 hour contest in the morning, and I decided to do this stream anyway because I promised I will do it. One last question from gaming. So I'm asked how to not silly in contests. Well, in order to find more detailed answer, you can check out my video about approaching Code Forces rounds. But if you want uh, some quick recommendations now, I mean, I don't know your level, but some of the most general advice I can give you is that uh, you should try to get good at the most common kinds of problems. Like, first few problems will always have simple concepts, and sometimes they can even have, like, I don't know, simple math or just some implementation. You shouldn't uh, be scared of problems. Like, no, nothing is going to be bad if you can't solve a problem. I hope I was helpful. I mean, just check out my video and probably other videos regarding competitive programming. Oh, I think I remembered another thing. Like, you should do virtual contests if you don't feel confident when doing contests. Does anyone still have any question? Okay, so one last question from how do I debug stuff? At first, I try to see if the idea is good. Like, if I proved that the idea is good, all I have to do is to debug stuff in my code and see what happens. Like, print some cout, like cout some intermediate answer. And if this doesn't work, I end up stress testing. And yeah, what skills apart from CP can I flex? Hmm. I mean, it's not like CP is the only thing I'm good at. I mean, I like playing strategy games. I'm also good at real life sports, and I like doing stuff. Like, being good at CP doesn't mean staying at home and doing code and math and school all day. Do I use GDB or just step by step COUT? Well, I got used to step by step COUT, and I use this. But you can also use stress testing if you learn how to actually create a stress tester. Yeah, I think I think I will end the stream here. As always, thank you for watching. If you liked the content, please check out my other videos, subscribe to the channel, and also join my Discord server. We can talk more. Until next time, see you soon and stay healthy.